Okay. 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 Fontaine. I don't know. Yeah, Fontaine. Don't mind.
Eccomi. Ciao, mi chiamo Daniel, sono in sala Lasagne. Va bene? Sì o no? A, B, C, D, E. Okay. So, welcome everyone back. And today we have our speaker, which is Mr. Fontaine. Python without file system. Go.
So this talk will be about, we'll explain how the source code of a web application can be migrated away from file system. For many years, it has been possible on mainframe to upgrade the source code without restarting the application. So I will try to explain how to do that in Python. So first of all, I will compare the file system and non-file system approaches and give advantages and disadvantages of this approach. Secondly, I will explain how a small application can be migrated away from the file system, and also explain the different mechanisms involved in such migration. And thirdly, I will show a real-world migration with EuroPython, something I have been working in the past year. First of all, there are usually many ways to deploy a file system web application, but usually it involves 3 steps. So first, the developers prepare a new release, which includes many bug fixes, for example, and after testing that no regression has been introduced, then the administrator will switch the production environment to maintenance mode, and at the end update the source code on servers. Once all the source code has been updated, the administrator will start the application on all the servers at the same time. Without file system, the first step is of course the same. What is more interesting is the second step, where developers update the source code which is stored in a database, and everything is reloaded automatically, so there is no downtime involved. About the database, any database can be used because the source code will be stored as a string. So about advantages and disadvantages, so the new approach provides several advantages. First of all, it greatly minimizes the administration burden because everything is stored in a single place, the database, and administrator feel less stressed because developers can take care of everything and fix the regression at the same time. Another advantage is that as everything is stored in the database, there is less inconsistency because the source code is not duplicated on all the servers. Everything is in the database, and we can upgrade everything in a transactional way. And also it's more scalable because when you have 1, 2 servers, it's not so complicated to administrate, but when you start to have a lot of servers, it becomes quite complicated, and it involves a lot of script and a lot of script to be able to synchronize everything at the same time. And at last, this approach doesn't require any downtime. So basically everything is reloaded online, so you don't need to restart the application. You just reload all the classes and modules. There are also some disadvantages. First of all, the most difficult part is maybe from a social point of view, because developers are used to use their favorite editors. So sometimes it's a bit difficult to try to switch to an all-web approach for this reason. It's a problem we had at NextCD. And from a security point of view, if you consider that editing the source code on the file system is performed like through SSH or with direct access to the system, usually it's easier to design a file system approach because it requires access to the server, which is more complicated to get. But this point is also about when it's about editing the source code on the new approach through a JavaScript editor, for example. I will give some more example a bit later about that. So in order to explain the different mechanisms involved in such migration, I will just take a very small application, which just a blog where you can create new entries. You cannot do much. Just a short example to explain the different mechanisms involved. So this code is using CherryPy and MongoDB, but you could, as I said before, you could use any database. It doesn't really matter at the end. So the first problem is how to reload the classes without breaking any instance. So there are several ways to do that, but the easiest way is perhaps to modify the class attribute on the instance itself. But at the end, it's quite complicated to set up because you need to keep track of all the instances and update them all at the same time. This could be done with GC module, but at the end, the code becomes really dirty and complicated to maintain. So the easiest way is to modify the basis of the class and insert a class which will take care of loading and unloading the code from the database. So before explaining how it's done, I will explain really briefly how attribute lookup works in Python, because this is important for the rest of the presentation. So when you try to access to an attribute X, it will first look into the instance namespace, which is a dict, and then it will continue in the class namespace, and then the search will continue using will continue following the search order defined by the MRO, method resolution order. So the MRO is just defines the search order of base class for an attribute. In order to create class dynamically, I will have to explain really briefly about metaclasses. I will not go into details because it will require a presentation by itself. So in Python, class are objects, which means you can create class like you create any object. And like a normal class inherits from object built in, meta class inherits from type built-in. And so basically, a class object is just an instance of a meta class. So the syntax is obviously exactly the same as a normal instantiation. So now I will explain how the implementation with meta classes will work. So first of all, we will wrap the main class I showed before, which is just the main application class, the main entry point. So we will wrap this class with a meta class called base meta class. And as you can see on the right, you can see the MRO. So for now, nothing is loaded, so the main class is not there yet. We just have a base meta class, which will take care of loading, unloading. And we have a ghost-based meta class, which will be only there when the object is not loaded yet. So the loading is done through getAttribute, but so for the first load, of course, it will involve a performance hit, but at the end, when it's loaded, you don't have the ghost meta class anymore. So when you try to access any attribute on the main class, it will load the class through getAttribute method. And at the end, at this point, the VMO will look like the one in the middle, which is the base meta class and a main class, which is the actual class. And when we modify the source code, we just call a specific method called restore ghost state, which will put back the ghost base meta class in the basis in order to allow to load it again. So the ghost base meta class, we don't define so many things here, except the constructor, which will customize the creation of the class. So for that, we define init and getAttribute, which will be attached to the newly created class. And this init and getAttribute will basically only load the class. Most of the logic is actually in base meta class. So we have several methods here. The most interesting one is restore ghost state, which will, as you can see, create a new ghost-based meta class and put it in the basis. We also have the load class, which will load the class from a dynamic module. I will explain in the next slide how the dynamic module works, because it's quite important. But basically, for now, it just puts the class into the basis. So we have at the end something like this, like the third one for the MRO. So in order to, because when everything is on the file system, you need to load, you are loading from you are loading the module on the file system, but in this case, everything is in the database, even modules. So you have to be able to customize the import. And this is possible with PEP 302, which define import hooks and allow to customize a lot the import mechanism in Python. So this PEP is divided into two parts. First, the registering hooks and the importer protocol. I will explain each of them because it's not... before explaining import hooks and explain the implementation which was done, so let's see how import works in Python quickly. So when you try to import a module, it will first look for the module in sys.module, and then if the module could not be found, it will look into the meta hooks, which is in sys.metapath. And this metapath only contains finder, which follow the importer protocol you can see on the right. each finder will return none if it cannot handle such module. Otherwise, it will load the module itself and return a new module. Then, if the module could not be loaded by the meta hooks, then it will look into sys.path and sys.path hook. I will not explain so much about that. I think it's more important to explain about meta hooks, because as nothing is on the file system, you don't need the sys.path hooks for this presentation. So some performance notes. First of all, it's better to use absolute import, because when you import a module from, for example, if you have a module A and you perform an import of module B, it will look into A.B and then B at the top. So it's better to avoid this kind of thing, because it will mean that find module, which is on the right, will be called for each import. So it's better to use absolute import, which is possible with a future extension. And another point is to filter as much as possible in find module, because this method will be called a lot at startup and also on reset, which means that if we have to filter as much as possible before looking into the database. And another point is to set up the hooks as late as possible to avoid breaking anything, and especially to reduce the startup time. This is quite important on large projects, of course, but for small applications, it's maybe not so important. So the dynamic package defines the finder and loader, so the two methods I showed earlier in the diagram. So this class, once instantiated, will put itself into metapath, and the finder is defined by find module. So in this case, we only check if the module can be handled by this finder in particular. So now the loader is more interesting, and it also gives a reset. So what we do here is just load the source code from the database and execute it in a new module type and put it into its namespace. About the reset only remove everything from sys.module and clear the dynamic package, basically this class. And then it will restore the root class, which is the main entry point. In the code before, it was called main. So now we can put everything together, but I think the code is. I think it's better to have a demonstration. So I think anybody can read it afterhand, if you wish. So about editing the source code, which is something really important from a developer point of view, of course. So you have several possibilities beside of export, import. One is a JavaScript-based editor. Unfortunately, there are only a few who support Python highlighting. In my opinion, the best one is Ace Editor, which provides something quite nice with indentation and everything. But some developers don't really want to use such things. They prefer to use their favorite editor. So in this case, there are several possibilities. The first one is about editing a single file. So you can define in your application put and delete, which are HTTP protocol. And you can also use a browser extension such as It's All Text, which allows to edit a text area in your favorite editor. I think the most interesting way is to implement WebDAV protocol, which allows to see all the source code as a tree, like you will see in the file system. And this WebDAV can be done, WebDAV implementation can be done quite easily with PyWebDAV, for example. So here is a really small web application. So we have just one blog entry, and all the source code is stored here in a small admin interface, which lists all the available files you can edit. So for example, if we take this class and we add a new method, the main class, at this point, getFoo is not defined, of course. Let's define it here. You can validate, and it will reset all the classes and modules from the database. And now we have everything was loaded properly. So as you can see, the application itself, as you can see here, there is a small message saying reset done. But nothing, I mean, EuroPython itself was not restarted at all. So it didn't require any restart at all. Of course, this is a really small application. We could do something, I mean, what we did in EuroPython is, of course, much more complicated. But this is just a small example to explain meta classes, import hooks, and show how we can do that, and how to edit the source code properly. So in this small application, there are several limitations. First of all, it doesn't implement completely the importer protocol. You have several extensions like getSource, getCode, which can be useful if you want to have introspection or PDB debugging. And as I said earlier, only modules are implemented, but it could be possible to implement a sub-package of the dynamic package I explained before. So you could do almost anything at this point. And one of the issues is that the entry point class is not, you cannot modify it because it was statically written into the startup code, which is on the file system. So this could be possible to have something completely in the database if you put some effort into it. And another thing is that everything could be migrated, including the framework, to the database. Something much harder to do because a lot of framework, I mean, most framework in Python do a lot of magic, which usually assume that everything is on the file system. So this could be more tricky to do. And another thing is, as you saw before, the reset just reset everything, all the module, all the class. When you modify only, if you modify only a single file, it will reset everything. So for this example, it's okay, but on a larger application, it could take some time. This is not really a problem from a user point of view because the code is not upgraded every day. But from a developer point of view, on a large project, it could be quite annoying. So this could be done by just implementing an introspection API. It's possible to do that, of course. So now I will explain how the migration of EuroPython has been done. And before that, I will explain really briefly what is EuroPython. So EuroPython is an enterprise resource planning free software which is developed by Nexity in France, Brazil, in several countries. It provides a lot of features like customer relationship management, method resource planning, and so on, which allows to manage a business completely with EuroPython. So it's used by several organizations and government agencies. And everything is based on a unified model. A unified model in this case is just in ERP5 we have only five basic objects, and everything is represented following this model. So you can represent almost anything with only five concepts. So about technical, everything is based on ZOP. The project is quite large because we have 8 million lines of code. And all the objects are stored in the database, but for indexing we use MySQL because with an ERP you often have complex query and search query. And about business template, a business template is just a collection of serialized objects. Each object in ERP5 has a portal type, and a portal type defines document class and a set of property sheets. So I will show how it works. For example, let's say we have a person here. The portal type of this person is also person. And here we define like the class, the document class, and some property sheet here. A property sheet is just a list of property which will be used later to generate automatically accessors. So for example, a property sheet can look like this. We have, for example, the address, and it will create automatically get address, set address, all the setters and getters automatically. Before explaining how it looks like now, I will explain how it used to be, just to compare. So when we try to access any attribute, it was first checking if the object is already loaded. If it's not, it will try to unpickle the object from ZODB, which means retrieving the object and loading it. So in this case, as you can see on the left, you can see that the class is order and the module is product.erp5.product.document.order. So this will define the document class which will be imported. And then for the document class and the portal type define several property sheets. So it will, as I explained a bit before, a property sheet looks like this. So for person, it will generate all these accessors automatically and will store everything in a dictionary. And so before, all the definition was on the file system, so this is quite different from here. This is after the migration, but this is just to explain the concept. So as you can see, we have a dictionary which is just a global variable. So to get an accessor, it will look into this dictionary, which means that we define something like get attribute, automatically override attribute lookup, and look into this dictionary to get the accessor. So now without file system, we have something much more complicated, but we'll try to explain. So when we access get reference attribute, it will first unpickle the object like before, but as you can see, there is erp5.portalType instead of product.erp5 before. So instead of this one, we now have a dynamic module. This dynamic module will just create the class on the fly, and it returns a class every time an attribute is looked up into it. So when we will unpickle the object, it will try to do erp5.portalType.order, And this will generate a new class and return the new class. So if this is a ghost, which means that the class hasn't been loaded yet, it will load it first by importing the document class. The document class can be defined on the file system, but we try to migrate more and more away from the file system, and put everything in ZODB. So then the accessor will be generated, but this time, instead of having a single property holder for all accessors, everything is in, we have one accessor per property sheet, instead of having a property holder for all the property sheet of an object. And so at the end, as we explained in the small example, we will have a quite complicated MRO. So as you can see, before we had something really standard, really easy to read, but everything was using get attribute, something like get attribute to look for an accessor and return it. Now the classes MRO is much more complicated because we insert class, we generate class automatically and put them in the basis of portal type, the one on the top. So as you can see, we have component order, which is a document class, which match product.erp5.document.order. So it's exactly the same, except that everything is loaded from database, from ZODB, instead of file system. And we also have the accessor order. So at the end, it means that we don't need the get attribute hook. We don't need it anymore because once the class is loaded, we have everything we need in the basis. So it avoids quite a lot of magic in get attribute and also improve performance because we don't need to call this method every time. So the reset is performed in two different parts. First, when we reset the component, this is exactly the same as before, namely that we take this module, we remove the dynamic module, then we delete the module from the package itself. And about portal types and property sheet, also the same as the simple example. So we store the portal type to ghost state. Before it was, on the simple example, it was just a root class that restore ghost state. But in this case, we have a dedicated module for portal type, which is erp5.portalType. And we clear all the property sheet module as well. So when you modify a component or portal type, the reset will involve putting a specific class, ghost base, which will define get attribute to allow to load the class from the database, from the ZODB. So now I will explain how we did the migration, because to implement this code and do the migration took about almost 8 months for 2 developers, because the code of ERP5 is quite large. So for portal type, everything is done automatically. We just define some hooks, some database hooks to load ERP5.portalType instead of using the file system class. About property sheet, it was done semi-automatically through a migration script. And for document, as you sometimes have to modify imports, it has to be done somehow manually. But this example is just to show how you can perform such migration and how we did it from the beginning. But to do the first step, each step took almost 2 months for each, 3 months for each. And the last step is ongoing currently. So So when migrating the source code of ERP5, we had several problems because as all objects in ERP5 have a portal type, and we need to get the definition of an object in portal type. So what we have is when we try to load, for example, foo portal type, it will access portal types foo to get its definition. And to get this definition, this portal types is actually an object whose portal type is typestool. So it will try to access portal types.typestool and so on. So it never ends. So one solution we did for ERP5 is for the first stage, to return a class without any basis. Just nothing in this class, that we return a reference to allow loading other objects. And at the end, the second one will be loaded completely with basis. So this is how we solve this issue. And we also have problem with backward compatibility, so we wrote a lot of unit tests to check everything, but still at the end it wasn't enough because we broke a lot of unit tests. So here we have, like before, the person object. So we have a property which, for now, doesn't return anything because it's not defined yet. So I will show how we can define it and how the reset process will work. So this person object has a portal type, person as well, like before. And this class is actually on the file system. So now I will define a new component here. So the editor we are using is ACE, but with ZOP, as you have WebDAV support, you can just mount it like a normal file system. And here we define getFoo property, which will be displayed after we set the class in the myProperty field. So if we change the definition of person portal type to use this new class, we just select it here. Save, and the save will trigger a complete reset of all classes. And when we reload this page, we have the value of the return value of the defined here. So the application was not restarted, and it was quite fast to reload everything. Okay. So in Python, we have many things which allow to have to implement something elegant to migrate the source code away from file system, like import hooks and meta classes. And it can be done, as I show in, it doesn't require a lot of code, like 100, 200 lines. Of course, if for ERP5 we have like, I don't know, 500 lines, maybe more for that code. So it can be more complicated, but at the end it's quite easy to do such things. And currently more and more applications get migrated on the cloud, so you don't have access to the file system. So this kind of approach allows to edit the source code easily, and without requiring file system level access to the source code. Another important point is that Another important point is that everything, this update, in contrary to file system approach, the update process of this new approach is done transactionally and doesn't require any restart. So it means that there is less issue for inconsistency, there is less inconsistency, less administrator work as well, less stress.
All right. Thank you very much. And now we can do some Q&A. Okay, straight away.
I find it very interesting, this allowing to reload the code that you've changed. I think that would be really nice if it was an independent project that you could use without having to code.
Actually, I would like to create a generic library to do that. I haven't had time to do it. But what we did for ERP5 could be moved out into a library. I think it's not so complicated to do, and it could be done in just a matter of time for me.
Nice. But this is just introduction. I have two questions. First is, did you consider using Fuse to mount this file system in this database files into the disk? And the other one is rsync or just some C# and using something to call pip install in all the servers really much work than all this? Because you did an insane amount of work to get this to work.
Yeah, but because for an ERP, it's quite usually it requires a lot of resources, so it's deployed on a lot of servers, and so we have to be able to synchronize everything without downtime, so 24 hours. So the problem with rsync is that we can rsync everything, but it's not transactional, which means that you can have inconsistencies, and moreover, it involves the downtime to restart the application. Of course, you could use load balancing to solve this problem, but all the user sessions are lost, and it's much more stressful, I think, for administrator because it involves a lot of work to make sure that everything is fine and working properly. With this, we don't need to care so much. Developers can just upgrade easily by importing all the source code, and this import is transactional, so it's all or nothing. So this is something important compared to file system approach. And okay, does it?
Thanks.
Anyone else? Okay.
Okay, so how does it all fit into your development process, version control in particular?
This can be done because we already have business templates, so everything is serialized as XML when you export it. So what we do is basically just export everything on the file system, and then we can use VCS. This solution is, for now, the one we are using, but it could be improved, of course.
I was thinking more about, do you edit code on the live system, or do you have some staging instances that you use for testing and then you push to
Yes.
production?
What we do is before pushing into production, we run all unit tests, of course, and functional tests to make sure that we don't break anything. And so by doing that, we can ensure that there is nothing broken before importing the new source code. And also, I forgot to mention, but all the reloading code and loading, unloading code is tested for unit test as well. So what we have is we have a lot of unit tests to make sure that in all the cases the reload will work fine without breaking anything. And the portal types and property sheet I showed before are currently used in production without any problem. The component is being worked on at this point. answer.
Does anyone else have a question?
Hi, I was just wondering about rollbacks, because sometimes you push to staging and test everything is fine and all that stuff, and then you push to production and you find out that there is a major issue. All the process that you described is more of sort of like iterative development and adding new stuff, but how do you handle rolling back on a larger scale?
Actually, I didn't talk about that because I didn't want to go into too much details, but we have in ERP5 we don't use we use sub-package. Before in the small application it was not implemented, but we have ERP5.component.something, and this something is just for example we can have version 1, version 2. So what we can do is before upgrade we save everything into a particular sub-package. When we upgrade it's another package. And if something goes wrong, we can just switch back to the new package. So this is something we have implemented, which is implemented, like it provides like snapshot at the end, So you can switch easily between one version and another just by modifying one field, and everything will be reset to take that into account.
Okay, anyone else? Okay then, and thank you very, very much. Been a pleasure.
Thank you very much.
Thank you. Sorry. Cheers. It was not really clear.